There's a standard build that I like to do for people that are looking for a regular computer that's going to stand the test of time. Something that, and when I say stand the test of time, I mean it's going to be good for an everyday use computer to get bills paid, to get work done in a home or a home office, where they're not going to need to worry about, unlikely to have any issues with breakdowns, unlikely to need any upgrades, and will perform quickly and quietly and reliably for a minimum of 8 years, right? That's the goal here today. So the parts that I've selected are very similar to other parts that you've seen me build before. And I want to be very careful that when I say the parts that I selected, they're really parts I recommended. The customers always decide what parts they're going to buy. It's always the customer's decision. And so if you think that this is an Intel channel, it's not. It simply isn't. I'm only building what customers order. But when it comes to the chip, when it comes to the CPU, whether it's Intel or AMD, it makes really no difference to me what a customer wants. I don't care. They all build the same. And as far as support goes, well, the new AMD chips, time can only tell with regards to longevity and reliability. There's no reason to suspect with AMD's history that there would be a problem. But many of the customers that I have already have Intel. They like Intel, and Intel has given them no incentive to want to go anyplace else. So they stick with what they know. And that's usually why you see it. All right, today's build. Again, it's a great workstation build that will run minimum without upgrades or problems, likely, for 8 years minimum. What is it? We're running the Gigabyte H370 motherboard. We're going to pair it with a 1 terabyte Intel 660p NVMe, which is cheaper than a SATA-based solid-state storage and 4 times faster. It's cheaper and faster, so it doesn't make sense not to go NVMe. As far as I'm concerned, SATA is dead. If I never see another SATA drive again, I'll be happy. I know there's still some folks out there that have mechanical drives for, larger storage capacity. However, with the exception of those folks, I would say if you're looking to build your own computer, go with that Intel 660p M.2. NVMe, always go M.2 NVMe on a new build. And if you're looking at budget, the Intel 660p can't be touched. And if you're looking at performance, the Samsung 970 Evo Plus can't be touched. So either of those two for either price or performance. They're both very reliable. The CPU we're using is the 8700K. The reason this CPU was selected is it fits within the customer's budget. It far exceeds their needs today, and it gives them a lot of room to grow over the next coming years. That's why I predict this will be a good system that they will not need to upgrade or replace, and probably won't need to repair for a minimum of 8 years. We'll see. Some things like the power supplies, that can go. There's not much you can do about it, especially if there's a power spike. But even that seems pretty unlikely with this quality of parts that we're using. We've got an Asus DVD reader writer. Customer still uses that on occasion. We've got 16 gigs of Corsair Vengeance RAM, and this is the 2400 speed. Again, really no performance difference noticeable by the end user, for most end users, going to faster RAM, but they all feel the hit in the wallet paying for it. So again, to keep it within the budget, for things the customers aren't going to notice, there's no sense spending money on stuff the customers won't notice. If it was an AMD system, the faster RAM would make a difference in benchmarks, but would the customer notice? That's hard to say too. Power supply, just a cheap EVGA 500 watt bronze. It's a very inexpensive power supply, but they've proven to be very reliable. And if it does die, I think it's a 3-year warranty. I can't remember. And beyond that, they're very inexpensive to just buy another one. In fact, I can buy 3 of those for the price of 1 Seasonic. That would far exceed the warranty, I believe, that Seasonic comes with for less than the price of the Seasonic. Over here, we've got the Mugen 5. That's the cooler you always see me use. It's easy to install. It's competitively and aggressively priced, and it's whisper quiet, and it's going to keep this 8700 CPU nice and cool. Where's the graphics card? graphics card is built into the CPU. This is not a gaming machine. It could be a gaming machine. If they slap a video card in it, they can do that. If the customer decides next year they want to play some AAA title game, all they have to do is buy a video card, pop it in. The power supply has got more than enough power, probably, depending on the graphics card, but probably would be fine without having to change anything. And so the machine could very easily become a gaming PC if necessary. Okay. The case, of course, the Corsair 200R. These are getting hard to find and they're getting expensive. The last one customer purchased was $75. So I don't know if Corsair has finally put a stop to making this case, but I did see other Corsair cases, prices also went up. So I'm not sure if that's an issue of supply or if that's an issue of tariffs. I have no idea what's going on with that right now. And as I learn more about it, I'll keep you guys in the loop. So I think what I'm going to do is I'll start by prepping the motherboard. That's been my latest change in process. So let me just move these boxes out of the way for right now. To prep the motherboard, I need the RAM, the CPU, the storage, which is the 660p Intel, the power supply, and the DVD drive. We'll put those in the case after we've prepped the board. So I'll set those back here. I'm trying to keep my work area as clear as possible. I need elbow room. I need to be able to move things around. All right, so we're gonna get started here. We're gonna prep the board. And for that, usually I like to install the solid state drive first. It's just easy to get it out of the way. So here I've got the H370 HD3 Pro motherboard. I like this board, especially for home users and business users, because it still has a lot of the older style ports that they might be using on their monitors. For example, let's take it out and show you. Here's our board. There's our documentation and driver disk. We don't use these driver disks anymore. I'm getting all the drivers off Windows Update. You would still use this potentially for any utilities from Gigabyte, but you could also just download the latest version online. There's our I/O shield. We'll keep the I/O shield over here because that's all part of case prep that's going to come later. And I'm going to build on top of the box so I don't scratch up my countertops. And please note the way that I handle the parts. The reason you don't see me wear an anti-static wrist strap is because I'm never touching any components directly. I'm only handling the edges of circuit boards so that if I am carrying a static shock, it has no place to go. If I touch a heat sink and the static spark jumps from my finger to the heat sink, it doesn't hurt anything. On the other hand, any of the points underneath this motherboard, all that metal, you want to avoid making any contact with it. Handle the sides, the edges, handle it by heat sinks. And if you have that much anxiety and you don't trust yourself, buy a $6 anti-static strap and wear it. There's no harm in wearing it. But it's also not a get-out-of-jail-free card. You can still static shock components wearing a wrist strap. And I know people on the internet, they like to think in the world of absolutes. Like, if you wear this anti-static wrist strap, it can never happen. It still can happen. It's less likely. It's more difficult. If you're not wearing it correctly, if you haven't grounded it correctly, there's a lot of variables involved in that. And also what components you're touching and how you touch them and how much voltage was in your body at the time. For the most part, electrostatic discharge is a problem in the manufacturing of the motherboards or the circuit boards. Once the parts have been soldered down onto the board already has grounding circuits on it. So it's much, much more difficult to static shock parts that are already installed in a circuit board. However, it's still possible. It's just less likely. All right, so let's get this out of here. And I'll show you why I like this board. So the board still carries with it some of the older legacy style connectors that many users are still holding on to. When it comes to a monitor, there are many customers today still using VGA monitors. And they're widescreen. I'm not talking about square screen, widescreen VGA monitors. And they work perfect, 22-inch wide, 24-inch wide VGA monitors in offices. They also have a PS2 keyboard. And I don't want them to have to replace their keyboard. People get attached to their keyboards. So if you look on this board, you'll see we still have that PS2 port, and we still have VGA, we also have DVI, and we have HDMI right there below the 2 USB ports, right next to the DVI. And that allows this backward compatibility that not only meets the standards of today, but helps make these upgrades and PC replacements far less painful to the end user. All right, so like I said, the first thing that I want to install is the solid state drive. This right here, this is the Intel SSD 6. It is the cheapest NVMe drive on the market that I'm aware of, and it just happens to come from one of the biggest manufacturers of chips in the world, Intel. This one is 1024 gigabyte, which is also called 1 terabyte. So let's get this out of the box. And this motherboard has 2 places that we can place the M.2. It can go here or here. This motherboard will not have a video card placed into it during this build. Even if it did, I would still go to this slot. So if the customer wants to add another M.2, sorry, the M.2 is down here. There's one here, there's one here. And this one that I pointed at, this is for a Wi-Fi card. It's a little Wi-Fi card. It looks just like an M.2 if you weren't, trained on what to look for. But if you look closely, these connectors are different. And an M.2 will not fit in there, even with a hammer. Don't ask me how I know that. All right, so we could put the drive down here away from the heat, but that means making it make it available to upgrade later may be a little more complex. If there's a graphics card right here, hey, my hand is blocking it, you can't see it, right? So imagine trying to get in this little space, this narrow space, to get a drive in there later. So I'll put the drive in there now, and then if they want to put another drive in, super easy, just take the side panel off, 1 screw, pop it in. Easy upgrade. You're in and out in 2 minutes. So for this, I need a number 1 Phillips screwdriver, and I'm going to take out this screw right here. Now the drive with this motherboard will work equally well in either this slot or this slot. It will not affect its performance. Depending on the motherboard you've selected, one of these may be slower. One of these may be SATA only. So if you're not using the exact parts you're watching me on my builds, then you need to look into your documentation or the support of the manufacturer to determine what your eligibility is with the parts that you've selected. So here we go. Let's get this opened up. This right here is 1 terabyte of storage. Remember when a 40 megabyte hard drive was 5 pounds? This is like 30 times the size of that. Anyway, we'll put this right in here. It only goes in one direction. There's a little slot, there's a groove, or there's a notch. They line up, kind of goes in on an angle. Line it up before you put any force on it. And then when I do put force on it, it's just enough to push it into the socket and watch those little gold fingers disappear. That's it. This little screw goes back in where we took it out, and all it's going to do is hold that drive down and secure it into place so it won't fall out or come loose in shipping or anything like that. You see, I didn't have to tighten it very much. And that puts our 1 terabyte of storage right in there. It's just that easy. And now we can move on to the next thing. I guess I'll go ahead and put the CPU in next. Now I'm doing this backwards. Ideally, when you do this, you'll be facing the same direction that the camera's on, because that's normally where I would be. So I'm going to do this backwards for your benefit. We're going to start by taking this lever, pushing it away, and lifting it up. And that's going to lift that whole cover up. In here, this is a bunch of delicate little pins down in there. Very, very delicate. That's why they're covered. Breathe on it wrong and you can damage them if you're a heavy breather. So what I'm going to do right now is I want to keep that open for as short of time as possible, because the longer it stays open, the more opportunity there is for a mistake to happen. So we're going to take the CPU out of the package. The package has 2 notches in it, and they're for your fingers to hold it by the edges. This is not coincidence. This CPU, and every CPU, has a little golden triangle in one corner. The motherboard also has a little white triangle right down here. You might be hard to see. CPU also has a little notch cut out here and a little notch cut out there, right there. They are not exactly aligned. One is higher than the other one. so that this can only go into the socket one way. On a socket 1151 board, the writing on the chip faces the same direction as the writing on the board. In other words, when you look at this motherboard and it says Gigabyte, ultra durable, see all that direction of that writing? So there's 3 different ways you can tell how this chip goes in. And so what I'm going to do is I'm going to line up that golden triangle with that white triangle, and I'm simply going to put 2 of the corners up against the edge of the frame. Then I'm going to just gently set it down. And sometimes it's hard to tell, is it seated correctly? So I can grab the edge of the internal heat spreader and just give it a little wiggle and see if it wiggles. Right now, this chip is not touching those little pins. It's just hovering above them. That's what this lid is for. When we bring this lid down, it's going to apply a bunch of pressure down around the edges of this chip and push it down into this socket so that the little metal pins will make contact with the little golden dots, the little landings on the underside, the underbelly of this chip. And then that's going to pop up this little plastic cover right here. This is going to come up all by itself. So we lower this down, and it's going to go right underneath this screw. That's what this screw is for. It solely exists to keep this socket pressurized, the retention lever pressurized over the CPU. So when I go to move this lever now, this lever has a lot of pressure on it. Well, not right there, it doesn't, but right about here. It's not loose like it used to be. And you got to use a little bit of muscle, not a lot, but a little bit. Some people are so afraid of breaking their electronics that if they exhibit even the tiniest bit of force, they're freaking out, they might break it. This is normal. This is going to have tension. And I'm going to push on it really hard. And you'll see that lid popped up. And then I'm going to hook it back underneath that catch. And that holds it down. This piece I'm going to put back in the motherboard box. Because if we ever have to send the motherboard in for a repair, you want to take the CPU out or you may not get it back. But if you ship it with those pins exposed, it'll guarantee they get damaged. In the motherboard manufacturer, every motherboard manufacturer will say, your warranty is now void. So if you are going to send this board back, take out the CPU and put this cover back on. You have to. Okay? If you want to be in warranty. That's all there is to installing the CPU. Now, we still have RAM to put in, and we've got the heatsink to install. Lately, I've been sort of changing this up a bit because there's a big CPU power connector right up in this corner. Right up here, right where my finger is at the top of the screen. And that can be quite difficult to get at once this motherboard is placed in the box, in the case. Because there'll be this big heatsink right here, and it'll block our access to this. It doesn't block it, it just makes it more difficult. It makes it a very tight squeeze. And I don't want to put the RAM in yet, because when I'm fitting the heatsink, I don't want to bump into the RAM and knock it around in its socket. These are delicate sockets, and RAM is a very, very delicate component. So what I'm going to do is prep this motherboard for the Mugen cooler right here. So let's back the camera off a little bit and I'll show you how I do that. The Mugen 5 is, in my opinion, the single best cooler you can buy for socket 1151 or AM4 chips. For what it costs and for what it does, this is as good as or better than those Noctuas and Be Quiets and others that cost 2 to 3 times more money. It installs easier, and I find it operates as good as or better than the big name brands with the big marketing budgets. These folks don't have a big marketing budget, so they don't have to pass all that expense on to you. You're paying for all that marketing, by the way. So let's get this opened up. Let me show you what you get in the box here. Right here, I've got a box of parts. Inside the box, we've got the cooling fan, which I'll set over there. And then the cooler itself, which is right in here. I think that Noctua, Be Quiet, all these other companies could learn a lot from the design of this cooler. Forget about the price. One of the things that Scythe does with this cooler that I absolutely love is the bracket is already installed for you, which everybody else makes you do it yourself, which is 2 more screws, and it can be a real pain in the butt. There's our cooler, nothing else in the box. Box is empty. But yeah, this bracket right here, notice that's already installed for us. Other manufacturers make you put this on, and it only goes on one way. You'll notice one side sticks out further than the other. You'll notice one side is cut down, so with other manufacturers, it's easy to flip this the other way or to flip it 180 degrees. You could put it on backwards 2 different ways. With this already being done, it's one less step for you to do. It's done right, so there's no concern about that. And it makes the installation faster and more likely to be correct. Less chance for the end user to do it incorrectly. Now, in this box, this is what makes the Mugen 5 special to me. You're going to get this long magnetized Phillips No. 2 screwdriver, and it's not just a cheap throwaway Allen key thing like Noctua gives you. This little cheap, like the cheapest tool you would get for one of the most expensive coolers you can buy. This is a much cheaper cooler, and they give you a screwdriver that you can use not just for building your entire computer, but also for fixing things around the house, fix your car, whatever you need a Phillips screwdriver for. It's magnetized. It's not like it just disintegrates over time, and it's not like it's so specialized like what Noctua sends you that you wouldn't think of using it for anything else because it's not comfortable. This, on the other hand, is very comfortable, and it's a quality screwdriver, and who would have thought you could get a quality screwdriver with your cooler, especially one as cheap as this one, price-wise. Then we've got a bag of parts, and we've got our documentation. Now, this CPU cooler will work on all the major CPU sockets out there, and that includes the LGA 2011 socket, including V3, the LGA 775, 11, 50, 51, all the 115X, and 1366, all from Intel. Over on this side, for AMD, covering AM2 socket, AM2 Plus, AM3, AM3 Plus, AM4, FM1, FM2, and FM2 Plus. So pretty much the only thing they're not covering is Threadripper. Most everything else, it's got brackets for. So in the bag of parts, they're giving us 4 fan hangers because you can add a second fan if you want to. We're not going to be doing that, so 2 of these we'll put away. We're going to need 2 later to hook up the fan. These brackets that look like parentheses, these are for mounting to AMD chips. We're not installing an AMD chip today. We don't need these. This bag right here, this bag contains extra screws for an additional fan. We're not adding an additional fan. We're not using this bag today. It goes over here. These 2 brackets we will use. This back plate we will use. There's a tube of thermal compound, not a little baggie that you have to cut open with barely enough to fit like other people do that charge you more money for their cooler. And then finally, we've got these standoffs and screws in this bag, and there are 2 sets of standoffs in here. One set of standoffs is tall, and the other set are short. The short ones are for socket 2011. The tall ones are for what we're building today, the socket 1150, 51, 52, all the 115, and then whatever number comes after that. You want the tall standoffs. So the little standoffs we'll put back in the bag. And so all of the stuff over here is out of the equation. We're not using that. Okay. And then these 4 screws, these are what hold these brackets onto the standoffs. So we'll get to that in just a minute. So I want to put this back plate on now, and that means I need the back plate and the 4 big standoffs. And then I'm going to come around here so you can see. And if you look on the back of the board, and once again, pay attention to where I'm touching this board. And I do it very thoughtlessly. It's very much an automatic thing to me. So I'm not really thinking about it. It's become a habit. But even if you look at my hand on the other side, I'm not touching any of the components on the board. I'm touching the I/O shield here, which again, you can static shock the top of this I/O shield all day. There's no harm you can possibly cause from that. If we look at the back of the board, look at this socket here underneath the CPU. And again, now I can touch this. This is all, there's nothing electronic here, just a big piece of metal. Avoid touching all the little circuits in the middle there, all those little transistors. But right around here, notice there's 2 screws and 1 screw. Right, see that? 1, 2, 3. That's what's holding this socket to the circuit board. And many of the back plates from third-party coolers will have holes in them. And those holes are there to align with the holes on the socket. Now this back plate also has little rubber feet, and those rubber feet are to go up against your motherboard. So if you're wondering, how do I know, does it go on this way or does it go on this way? Well, if we put it on the other way, it would be metal against metal. That would be bad. You'll also see in each corner there are 3 holes. That's to fit all those different socket types. If you're building the same system I am, or a similar system using a socket 1151 chip, or 115 anything chip from Intel, you're going to use that middle hole, the hole in the middle. So what I'm going to do is align the 2 holes here with these 2 screws that are holding the socket in. Now, that's not critical. It is possible that I could install it another way and it would probably still work. But if you're going to do it, I'm suggesting you do it right, so you don't find out what potential problems could exist if you do it wrong. There's a reason those holes are there. Whether or not you understand that reason is not important. Now, I'm going to go ahead and hold that in. I'm going to put pressure against it. See where my thumb is and see how I'm holding on my right hand. In fact, this hand right here, watch where my fingers are. Pay attention to that. Look at my thumb. Look where I'm holding the board. Now I can bring the board down like this, and while I'm holding that, I can grab one of these standoffs and just place it into one of the holes surrounding the CPU socket. I'm going to flip it back up. This does take a little bit of practice to do it by yourself, and I want to make sure that that comes through on the center hole up there in the corner. And you can kind of see the reflection. It's coming through right through the middle. Now, with just a couple of turns, don't turn it too many times, I'm going to go do the opposite corner right here, right? So we were in this corner. Now I'm going to do that corner. And just make sure you align that back plate so that that screw is coming through that middle hole right there. And with 2 screws in opposite corners, I can let go, and that back plate will stay exactly where I need it to, so I don't have to worry about aligning it with any more standoffs. I can take this standoff and blindly put it in from the other side without looking, and it will automatically align to that middle hole now. I might have to, the screw's a little short, so I kind of have to meet it. But I shouldn't have to adjust it up or down like I was having to do, because the other 2 are securing the location of the bracket. Finally, I've got the last standoff, and that's going to go right back here. And again, just turning it, it should automatically align with that middle hole. And now that I've got them started, I can put the motherboard back down, use the included screwdriver, and start turning these. And just turn them all a little bit, just go around. And then once you start feeling them tighten down, then come back around again, and just keep doing the opposite corners so that you don't want one side of this to warp at one side. So if you did 2 screws side by side before you tightened anything else, it may sit crooked. And it would be very difficult for you to see that with the naked eye. You would just wonder why your cooling is not very good. And you could take the cooler off and put it back on. It's not going to help until you reseat that mounting bracket correctly. So just bear that in mind. This is one of the few times in a computer build where the order of tightening the screws matters. Don't over tighten. You can crush the motherboard, or you can snap the heads off of the standoffs. So it's just something you feel for. It's tight. It's not going anywhere. Now I can take these two brackets. Again, these can go on. I could flip that upside down. That's not the way it goes. I could flip it backwards, but that's not the way it goes. It goes this way. This little indentation right here, it goes over this bracket. Remember that, not the bracket, this lever that I lifted up, it's gonna go right over that lever. And you'll see there's numerous holes in here. That's to fit all the different sockets. We're gonna go on that, I think it's the inside hole. All the, on the last hole at the inside. And then we'll take these screws here. They look like this. And I've grabbed two of them. And I'm going to put one. I'm going to put one right here. And the other one's going to go same position, opposite side. And when you tighten these, they will come to a dead stop. So you don't have to wonder. These standoffs never come to a dead stop. You can just keep cranking and cranking on them until you crack your board or break the head. So once you reach a certain level of resistance where it feels like, then you have to stop. With these just stop on their own, and there's no doubt you can't go any further. We're going to do the same thing on the other side, once again with that indentation right here, facing towards the CPU. Screws go in the same holes in the same place as though you were holding up a mirror to this one. Notice I just start the screws. That way I can move this around so it can line up with the other one. Once the other one's started, I can tighten it all the way down and then tighten the other one. That preps the installation of our cooler right here, because these two holes are all we need for those two screws, and that makes that install super easy. So I'm not going to put the RAM in it yet, but I will open the RAM sockets up. Just open all these retention levers up. Just easier to do it now. I'll pull this panel out right here. Come on. Thank you. And we'll slap a DVD drive in there, which requires a whole lot of talent and education. Requires at least 3 years of school at DeVry, so you can learn how to do this. Uh-oh, might be time for me to go back to school. Well, that's done. Graduated. What else? Power supply. You can put the power supply in now if you want. Or we can put the motherboard in, it don't matter. I'm gonna put power supply in because I feel like it. Because I'm a rebel like that. Can't stop me. And in this square box is a rectangular power supply. I'm not sure how they did that. Got a bag of screws to mount the power supply. We're going to use that. Empty box. Okay, here's the power supply. We're going to put that in here real quick. Use the screws that came with it because they're black and they match the case. There's 4 of them. Go to the corners. That corner is offset. The one up at the top left is off by about 1 inch. That's how they all are. So that preps the case. Our I/O shield is installed, power supply is installed, optical drive is installed. I'm going to lay this flat. I apologize that you guys aren't going to get to see a very good angle, but I just want to get this done real quick. So I'm going to take the board. Again, watch how I hold the board. And I'm going to set it in here, lining up the I/O shield, lining up these I/O ports with the I/O shield. You can grab it by the PCI slots here, the way I'm holding it. We can bring this down. Now, you saw me put it in with the rear end facing down. It really needs to go the other way. So I'm going to turn it so hopefully you can watch this area right here. And I'm going to grab the edges of the board. And again, I'm going to tilt the back of it the opposite way. So the back of it's lifted up and the front of it is down towards you. And I'm going to line those I/O ports up with the holes. And I want to just watch for any grounding straps. I think we're okay here. I think. And I want to come around and take a look at that. Make sure that I'm aligned, that all the ports are coming through the holes okay. And if so, I'm going to push the board this way and then down. And it should seat on one of the posts for the standoff, just like that. And make sure that you can access everything. Make sure that there's no grounding straps blocking any of your ports. You might need to get a flashlight. Take as much time as you need. This motherboard also has that extra hole that I talked about in the last video. It's an extra mounting point that this case does not support. So I'm going to grab one of my little plastic standoffs. I don't know why Gigabyte adds this extra hole. They're the only manufacturer that I'm aware of that makes motherboards that does this. I'm going to take the board back out so you can see. Okay, this board has several mounting holes. One here, one here. It's got one here, one here, one here, one here, one here. You see how these three align? They go right in a straight line. 1, 2, 3. But this one's all by itself. There's no other hole on any other motherboard manufacturer located right here. Only Gigabyte puts this hole here. So this one, and this one are all in a straight line. There's 3. 1, 2, 3. These 3, 1, 2, and then offset at the top, 3. So what the heck is that one for? So if you're building along with me and you don't have one of these little plastic standoffs, you don't need to use it. It's not necessary. You're just going to leave that hole empty. But because I have this, I'm going to pop it in there. And that gives it that little leg that it can sit on for added support. Doesn't hurt anything to have it. Doesn't hurt anything to not have it. Now, I'm going to repeat putting the board back in. And let me just double check my ports, make sure nothing's blocking them. Sometimes the I/O shields will have these little metal pieces that stick out for grounding. And if they bend down as you're installing the board, they'll cover up your ports. They could cover up your HDMI. And in fact, I did it right here. I've already done it. Let me show you. If you look very closely at this USB port, there's a piece of metal right here. And now I can't plug anything into that hole. So if I mount this motherboard with the screws and then finish building the system and cable it and do my cable management, I may not even realize until one day I reach back here to use this other USB port, I can't use it. Then what are you going to do? You basically have to take it all back apart again. So this is something you want to watch for while you're building. If you bought a motherboard that has a built-in I/O shield on it, this is a problem you'll never have. So I'm going to take the board back out. And right here, this little tab right here, see it sticking down? I'm going to bend it up with my finger so you can't see it anymore. Now, I want to bend it down just a little bit because it is supposed to make contact with the top of the I/O shield for a grounding point. Now let me make sure that when I place it into position that I have full access to that USB port now. And let me make sure I didn't bend any others in the process, right? Everything looks good. All the ports are poking through the holes, all the I/Os here coming through, the videos coming through. This is all aligned, and that means now I can take the screws to mount the motherboard. Now in the case, I forgot to take out the little box right up here. There's a little box in the hard drive bay, and that's got all the screws we need to mount the motherboard or any drives that the case you bought supports. So because different cases support different motherboards and different sizes and different amounts of hardware, they include the screws that go with the case. The screws do not come with the motherboard because they don't know what kind of case you're using. So every case manufacturer includes screws for that case and for the amount of hardware that case is designed to hold. So if we open this box up, you'll see we've even got some free nylon zip ties for cable management that Corsair has included with the 200R. So we will definitely use those a bit later. We've got extra screws for adding another fan to the front. We've got extra screws for adding another fan to the sides. We've got extra standoffs for larger motherboards. We don't need any of this on this build, and we'll set it aside. Now that leaves us with just 2 bags of screws. One bag of screws is going to have a fine thread. The other bag of screws has a coarse thread. We want the coarse threaded screws for the Corsair case to mount the motherboard. And I'm going to need how many screws? I'm going to need 1, 2, 3, 4, 5. Now, I would recommend if you're a first-time or novice builder, use a mechanical screwdriver to tighten all screws. You'll see me use this electric screwdriver. This is an expensive electric screwdriver with a clutch, but it would still be easy for somebody to cross-thread a screw if you couldn't feel when that's happening. You know, that you can only feel it with experience. So after you gain some experience, and if you're building a lot of systems, you definitely want to move to something electric so that it'll save you from any carpal tunnel syndrome or repetitive stress disorders. Of course, it's always safe to use an electric screwdriver when you're taking screws out. It's when you're putting them in, you've got to be very careful. You'll notice I'm only starting these screws, again, so I can wiggle the motherboard if necessary and adjust it for all of the mounting holes to line up with the standoffs behind them. Once they're all started, I can tighten them all the way down. It doesn't matter what order, just don't forget any. This screwdriver will automatically turn off when it hits its preset clutch setting, which is the number 3 that I use. That's it. Board's installed. Let me show you. Now I want to hook up the 2 main power cables to this motherboard, which is the 8-pin up here in the corner. That's that one I said was going to be hard to get at when the heat sink's in place. So we can pull this out, pull all these cables out. And I'm going to plug this big 24-pin power cable on right now. Just get that one out of the way because it's easy, super, super easy. It's the only connector that looks like it looks, and it only goes on one direction, and that's with that clip facing the edge of the board, the outside edge. I was trying to put it on backwards, but I figured out real quick because it absolutely will not line up if it's backwards. So that one's on. And then I need that 8-pin CPU cable. Let's see, that's for a graphics card. Here it is. This is a good time to make sure these cables are not all woven together. Get them all straightened out now so you don't have to do it later after they're all plugged in. And then you get the benefit of doing it twice. We're going to run that right up through that hole there, and we'll bring it up through here and up into this corner, just like that. Okay, come back around. Bring this cable out, turn it around. Again, the clip is going to go towards the outside edge of the board. It goes way up in this upper left corner right up here. And you'll see, if you've watched my other videos and you've seen me spend 5 minutes putting that on, that went on in seconds because I didn't have that big heatsink that I had to work around. I can also hook this rear fan up if I want to right now. Take this cable, take the wire tie off of it. And looking on this board for a fan header, where did I do it last time? That's our CPU fan header right up here. It's white. I thought there was another one. Yeah, there's one right up here. There's a fan header. But it's going to, when I plug that in, it's going to leave a lot of slack. This may be a good time to use one of these nylon zip ties that were included with the case and fold this cable up real nice and neat. Now, cable management is really subjective. It's up to the user to decide what looks good and, you know, how much effort you're willing to put into it, how much time you're willing to put into it, how important it is to you. There's not any one way to do it correctly. And now I will just plug this fan right up here in the top corner onto this fan header. This is very difficult for me to see because it's a 4-pin connector on the board, but this is just a 3-pin fan. And that's okay, there's nothing wrong with it. You want to make sure you're on the right 3 pins where the fan won't turn, won't damage anything, it just won't turn. And then you'll have to go back and take that off and put it back on. And remember, once the heat sink's in position, that's going to be a little bit more difficult to do than it is right now. So I just get my flashlight, want to make sure I'm on those, the far right 3 pins. The last pin on the end of the socket should be exposed. That's the pin closest to the edge of the case. We've got it on correctly, that looks good. All right, let me get the thermal compound on. So we'll grab my nitrile glove. Don't want to use a rubber glove or latex, we want to use nitrile. We're going to put a little dab of this thermal compound right there. And we have plenty of extra if we ever need to reapply it. And I'm just going to smooth that out. Finger paint. Cover the whole surface of that internal heat spreader. Might have put a little too much on there, so I'll use a clean finger to just kind of wipe off a little excess. And then I'm going to just tap on it and make it tacky. That's going to help prevent any of these so-called air bubbles that naturally go away when this stuff heats up. And, you know, when it hits 80 degrees centigrade, this becomes quite viscous and it shifts around. So the idea that you get an air bubble that won't move is just a lack of understanding thermodynamics. But you can see all the extra thermal compound on my fingertips. That stuff can be hard to wash off your skin. So by using this glove, it's clean. It doesn't, I'm not putting any any oils from my skin. We want to make sure that the surfaces are 100% clean. If you have touched the surface of the CPU, even by mistake while you were installing it, grab some rubbing alcohol and a Q-tip and just clean it off. The rubbing alcohol will evaporate and you'll have a nice clean surface. And that will make your thermal compound much more effective when it has clean surfaces. That's why the bottom of this heatsink has tape on the bottom, and that's to keep it free of any contamination. So you leave that tape on until it's time to install. You've seen me work on machines that customers have brought me where the tape was still on, the customer didn't remove it. Customer says, oh, the computer works, so I must have built it right. That just because the computer works doesn't mean it's working as best that it could be. So this is very easy to just peel that back and take it off. So building a computer is very simple, but you have to watch those little details. The details of the standoffs, the details of the tape. If you can just be a detail-oriented person, you don't have to be very well educated to do what I'm doing here. It's very simple. Now, I'm going to have to lay this again flat because this is heavy and I don't want to try and mount it this way. You would never do it that way at home. Unfortunately, it doesn't give you much of a view to see what I'm about to do. But I have several other build videos with wonderful close-up shots of exactly how this goes in. So I'm going to just put that in right now so we can move on as quickly as possible with the rest of the build. And that's where this included screwdriver comes in handy, because there's a little hole on the top of this heatsink that's going to go down to the mounting screw, and I want to make sure that I've got a screwdriver that's long enough. And so when you buy the Scythe cooler, you don't have to worry about it because they give you one. Once again, start both screws. Don't tighten down one side completely. Try and just go back and forth between the two mounting screws. Take a few turns, go to the other side until these screws come to a dead stop and they won't turn anymore. You cannot over tighten the screws on the Mugen 5. They will actually come to a full stop. And that's it. And that's what it looks like once it's installed. Now I can put the fan on, and then we can put the RAM in, and then we hook the switches up. We can do our first test fire and see if it works. So now we can put the fan on, and that means I got to put these little wire hangers on. And I want the fan to blow the air this direction. I want it to bring air in through the radiator. And then this fan is also turning in the same direction, pushing air out the back. So all the airflow is going to be this direction. So that means the fan has to mount with this part visible. And the part with the support brackets will go up against the right side of the heatsink here. And I think I'll take this opportunity right now to just zip tie this cable so I can take the wire tie off of it. All right, I'm gonna just grab these wire hangers and let's see, how am I gonna put this on? It's gonna go on this way, so these are gonna go on just like this. One on this side, and then one on the opposite side. Look at that. And when I put this on, I want the cable to run the shortest distance from the fan to the motherboard, so our cable management will look good. I want the fan, like I said, with the support brackets facing the heatsink. There's little cutouts in the Mugen 5 that's going to rest perfectly. It helps you to align your fan so it'll fit in there just perfect. And then you just grab one of these wire hangers by the tab, pull it back, and it locks right into the grooves on the heatsink. Finally, take the power cable that powers the fan and plug it into the CPU fan header on the board. On this board, that fan header is right near your fan, right near your heatsink, and it's a different color than all the other fan headers. This one is sort of a off-white color. It's a 4-pin fan with a 4-pin connector. It only plugs in one direction. It's keyed. And then you can just sort of fidget with your cable a little bit to do your best to hide it. And that's what that looks like. It's beautiful. I can hook up our front port audio connector right now. Coming around the back, we've got our USB 3 right up here. That's this cable. And our audio, that is up here. That's this cable. So I'm grabbing that audio cable. It even says audio right on the end of it. And I'm going to run it right down over here. I need it to get as close to this corner as I can get it. And since there's a little gap, I'm going to use it. Not all cases and power supplies have that gap. So I'm going to bring that over here. And it only plugs in one direction. And I just wiggle and push until it bottoms out against the board. And that's all there is to hooking the front audio up. Right here is our USB 3, but before I plug that in, I'm going to put the RAM in. And we're going to use either the black sockets or the gray sockets. Whatever sockets you use a socket, skip a socket, use the next socket. That's how dual channel works on DDR4. Some motherboards recommend you use a certain set of sockets. Look at your motherboard manual and it will tell you. This motherboard manual says it doesn't matter if you're only using 2, just use one, skip one. So you're going to use, in this case, the black ones or the gray ones. If you've got 4 memory modules, obviously you use all 4 sockets and you don't have to worry about those little details. This Corsair Vengeance RAM has a little sticker covering the Vengeance logo so it doesn't get scratched. You can leave it in place if you want to. It doesn't hurt anything. I like to peel it off because it bothers me. The RAM is keyed. It's got a little notch in it so that it will only plug into the socket one way. You see that notch right there? Don't touch the connector. You can hold the RAM because it's got a metal heatsink on it. You can hold it any way you want to, but don't touch those gold contacts. This RAM will only fit in one direction, so make sure you align it properly. Make sure all the retention levers are in the open position. Once it's aligned in the track, you can just push down one corner and then the other corner, and you should hear it click. This is hard to do standing up. If this is laying down, installing the RAM gets a lot easier because then I can use my thumbs and I can just push down on the corners and you should hear it. Then I'm going to skip the next socket, which is black, and go to the other gray socket right at the edge of the board. And again, I'm going to remove that clear plastic over the logo because it bothers me. Rotate the RAM in the proper orientation so that it fits in the socket and aligns with the notch correctly. Set it in gently, make sure both sides are in, and then use your thumbs, push down one corner, and then the other corner. Then we can close the other retention levers up so they don't hang in the way. And that installed 16 gigs of RAM, just like that. Now I can take this USB 3 connector, we'll run it right through this hole right here. We'll push that through. And that's going to go only in one direction, right here. It's got a little notch on one side, so it can only plug in one way. There's no clip or anything. It just sort of fits in there with friction. And if you experience any resistance, do not force it. You could have a bent pin, or you may have just bent a pin. So you'll see I'm wiggling it left and right while I push on it, and then it just sort of gives a little click. Sometimes they do that. Depends on the board. And then I've got the, what's left? Just the reset switch, power LED, hard drive LED. And we'll run those right down on the bottom here. Let's get these cables hooked up real quick and then we'll test fire this bad boy. Power switch goes there. Reset switch goes right underneath the power switch. Hard drive LED, bottom left corner, with the positive cable facing the edge, outside edge. And then the power LED is going to go on just above the hard drive LED, positive above the positive, negative above negative. Remember, positive always goes to the outside edge. If you get these backwards, your LEDs simply won't light up. It won't hurt anything. They're just not going to work. That's it. You think it's going to work? You think it's going to boot? Now, I still have to hook power and data up to the DVD drive, but I don't have to do that right now. That will not impact the ability of this machine to turn on and install Windows. So why hook up something we don't absolutely need? If the machine doesn't work, it's one more thing we have to figure out if it's causing the problem. So let's see if what we've done so far works. Basically, we've done it all except the power to the DVD. So last thing. And we'll flip the switch to the on position, make sure no smoke comes out. Step around. Now I'm going to activate your monitor at home. Are you ready? Now your monitor says no signal. That's okay. Let's hit the power button. See what happens here. Fans are turning. Power light is on. Now I'm going to give it a minute for it to recognize the CPU that we put in, the amount of RAM. There it is. It's starting to boot. And it may reboot itself 2 or 3 times. Leave it be. Just let the machine continue to turn off and turn on. Give it a good 2 minutes if need be as it recognizes all the new hardware you've plugged into the motherboard. And then finally, it should get us to the BIOS screen. This is not the BIOS screen. That's a post screen, a power on self-test with a Gigabyte logo. And you'll see it keeps turning off and turning back on. And then finally, it should try and boot, realize there's nothing to boot to. We've got a solid state drive with no partition, format, or Windows installed, and it lands us into the BIOS. Now we don't need to worry about setting the date or the time because that will all happen when Windows is installed. It will automatically set the date and time for us. So there's really nothing we need to do right now other than maybe we can check and see if we've got the latest BIOS installed. So if I use the mouse and make sure that the mouse is working, go up to BIOS, no, go up to System, and it says we're running version F13. So what I'm going to do is I'm going to go to Gigabyte's website and I'm going to check to see what the latest BIOS is for the H370 HD3. So let me do that right now. H370 HD3. The latest BIOS is F14, so there is a newer version. I'm going to grab that real quick and put it on a flash drive, and we're going to update the BIOS. So let me take the flash drive back out of the streamer, and what I'm going to do, so you guys can watch, is I'm going to take this flash drive that has the BIOS on it, and I'm going to plug it into a USB port back here. Shouldn't matter which one. And then we'll go back to this screen, and we'll go down here. Oops, didn't mean to do that. Classic mode, Q flash, update BIOS. It sees the flash drive, it sees the BIOS version, F14, double click it. It verifies it's the right BIOS. You'll see in yellow it says intact, that's the default. We click on that, and now we wait as the BIOS updates. Do not turn the machine off, do not play with the keyboard or the mouse. Leave it alone. The worst thing that can happen right now is you lose power. I haven't lost power in this house in a long, long time. If you live in an area where you experience frequent power outages, then you should be running through an uninterruptible power supply, a battery backup essentially, so that it won't impact your ability to damage anything or to cause an issue if the BIOS update is interrupted. This takes about 2 or 3 minutes, so you just need to be patient, let it be, let it do its job. Walk away, find something to distract yourself or stare and watch, but leave it. Let it do its thing. If you want a greater chance of success, leave it alone. See, it's going to reboot itself. Again, don't touch anything. It's going to do everything on its own. There goes its first reboot, and it may reboot 2 or 3 times as the BIOS updates. Different manufacturers may do it slightly differently, and depending on the age of your machine, modern computers should update in a similar way. When it says no signal, that means the computer's been turned off or reset, and now it's rebooting again. So every time you see no signal, it's resetting itself. That's normal. Don't try and fix it. It's doing what it needs to do for the BIOS update to be successful. It takes us, when it's done, back into the BIOS screen, and once again, if we go back to System, we can now see we are running version F14 right there. Now with that done, I can turn this machine off. Let me show you. I'm going to turn off the computer, and all the fans are going to stop. I can take this flash drive out. I am done with that, and I'll set it aside for right now. And I've got my Windows 10 on a flash drive right here. You can build your own Windows 10 installation media for free, illegally. You just need to buy a key to activate it. And I've got videos that detail exactly how to make one of these. I'm going to plug it into a blue USB port here in the back. I want it blue because the blue ones are the USB 3. That's a fast flash drive. I want this to happen as quickly as possible. We're going to turn this back on, and then we'll flip you back over to that video feed. And now the only thing this computer can boot from is that flash drive. Nothing else is bootable. The only bootable potential is that Intel M.2 drive, but that's empty, it's blank, because it's brand new out of the box. They don't know if you're a Mac user or if you're gonna load Chrome OS on it. They don't know what you're gonna do with it. So it's blank. Windows will automatically partition and format that blank drive and make it bootable. And that's what we're going to do right now. So here we just go with all these defaults and click next. That's the first step, and then we'll hit install now. Now it wants a product key. I advise everybody to never enter their product key during an install. Wait until the install's done. So right down here it says I don't have a product key. I'm going to click that. It's like, well, if you don't have a product key, you need to tell me what version of Windows your product key is for. Because if I put on Windows 10 Home and I try and activate it with a Windows 10 Pro key, it's not going to work. I happen to know I have Windows 10 Pro keys. Here in the US, these are the only two options you should be considering. Everything else is specialty or for Europe. And then I hit next. And it's going to say, do you agree to the end user license agreement? So make sure you read and understand all of this. And all of this, and all of that, and all that stuff in bold, and all that. And then when you do, click accept and hit next. Always choose custom install. Always, 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 we want a custom install. It sees our brand new 1 terabyte Intel 660p. It's already highlighted. It is the only choice. If I was going to put more drives in this computer, I would not hook them up. Not yet. Because then it would offer me every single drive, and I'd have to be very careful over which drive I select. By only having one drive hooked up right now means you can't screw it up. It's the only place it can install, and hit next. Now Windows is going to automatically partition, format, and install Windows 10 onto that Intel NVMe drive. Just that easily. That's all there is to it. That's quick, right? United States, yes. US keyboard, yes. Any other keyboard layout? No, just English. We're gonna say I don't have the internet for right now. Continue with limited setup. That means we're not signing into a Microsoft account. We'll give this user a name. We'll say Terry. Enter. No password. Customers can set that up themselves if they want that. We're going to say no to this. Decline Cortana. And I turn all of this off but the location. Location will set our time zone and everything for us. And if the customer wants to type in, where's a Taco Bell near me or whatever, you have to tell it where you are. With location services on, it's a convenience. You don't have to tell it where you are. With Windows 10 now installed, I can remove the flash drive. And I can plug an Ethernet cable in here and we can grab all the Windows updates. And we'll give that a second. Go to Windows Update. Check for updates. With these Windows updates installed, it's just a matter of getting the DVD drive hooked up, getting the cable management done, and of course I will run Prime 95 and I will run, I won't run the benchmark for graphics because this doesn't have a graphics card, but this will be the exact same results because it's the exact same parts of Saturday's build, so I won't repeat that here, mainly because I'm out of time. Thank you all for watching. I hope you have a great rest of your day. I will see you all again very, very soon. Until then, bye for now.